Let's practice writing reference angles together. For number 1, we have this angle of 300 degrees. Let's start with the coordinate plane here, where we're going to have 0 degrees all the way to the positive x-axis, 90 for the positive y, 180 for the negative x, and then 270 degrees down here over on the negative y-axis. So where is this 300 degrees going to lie? Well, for starters, we're going to make sure that our angle starts from 0 degrees here. And we're always going to be moving counterclockwise, so moving 300 degrees in this direction. We're going to be all the way over here into quadrant 4. So when we go ahead and put where 300 degrees is, that's going to be 30 degrees past 270 degrees, maybe something like this. So this angle that we're given of 300 degrees, that's right over here. That's this angle all the way around, so this is 300 degrees. Now, while that's the original angle, what's the reference angle? Now, the reference angle is always going to be relative to the x-axis, so it looks like our angle here is going to be formed with the x-axis, in this case the positive x-axis, so this is going to be our reference angle here. So if we go ahead and mark that down, this is going to be our reference angle, and so if we knew we had 30 degrees past 270, that this over here must be 60 degrees. The reference angle for 300 degrees would be 60 degrees. Here's number 2. For number 2, we have the angle of 210 degrees. So looking at a coordinate plane, again, we're going to start by drawing our first part of the angle measured. That's going to be on the positive x-axis, starting at 0 degrees. And so we're going to be 30 degrees past 180, since 30 plus 180 is going to be 210. So this is going to be our angle measure right over here, from here all the way to here. That's going to be our theta. Our theta is 210 degrees. And so to figure out our reference angle, we have to see this is going to be relative to the x-axis or horizontal axis. So our reference angle is going to be right over here. So labeling this is going to be our reference angle. This is going to be 30 degrees. So when theta is equal to 210 degrees, the reference angle is going to be 30 degrees. Here's number 3. For number 3, we have this angle measure of theta equaling negative 120 degrees. So let's go ahead and put this on a coordinate plane to see what this looks like. We're going to start by drawing our initial ray here going on the positive x-axis. Now, because we have a negative angle, we're actually not going to be going counterclockwise. We're going to be going clockwise 120 degrees. So starting from 0 degrees, we're actually going to move 90 plus another 30, which makes 120 degrees in this clockwise direction because we have a negative angle this time. So because we had a negative angle measure, we're moving clockwise instead of counterclockwise. So this angle right over here from 0 to this right over here, this is theta, and that's going to equal negative 120 degrees. Now again, the reference angle is going to be relative to the x-axis, which is right over here. So our reference angle is going to be this angle measure right over here. Now, if we know we are 30 degrees less than 270, then we must be 60 degrees away from this 180 on the other side. So this angle right over here, this is the reference angle, and that's going to be 60 degrees. When our angle measure is negative 120 degrees, the reference angle is going to be 60 degrees. Here's number 4. For number 4, we have this angle measure of theta equals negative 240 degrees, so another negative angle measure. So just like we've been doing, let's go ahead and see this positive x-axis right over here. And because we have a negative angle measure, let's go clockwise instead of counterclockwise. So let's move 90 plus another 90, that's 180, plus another 60 degrees to get to 240 here. So if we go ahead and draw this where 240 or negative 240 rather ends, that's going to be somewhere over here. So traveling from 0 all the way around here, this is going to say that theta, that's that angle measure, that's equal to negative 240 degrees. Now, what about the reference angle? Well, the reference angle is always relative to the x-axis. So let's go ahead and see if this is where the x-axis is. The reference angle is always going to be just relative to that from wherever our terminal side is, or the ending is. So right over here, that's going to be this angle measure coming down. Now, we did end up going 60 degrees past 180 earlier, so this is going to be 60 degrees. And so 60 degrees here is going to be our reference angle. Now that we've worked on some examples with some angle measures that are in degrees, let's try practicing some that are in radians instead. Alright, so measuring in radians now, we have 0 pi over here on the positive x-axis. Pi over 2 is the same thing as 90 degrees. Pi is equivalent to 180 degrees. And then we have 3 pi over 2. That's going to be our 270 degrees. And then at 0, this is the same thing as 2 pi or 360 degrees. So in case that's helpful as a reference point. So our angle here is going to be 7 pi over 4, which is almost 2 whole pies. It's just a quarter short here, right? So let's try to think where we are going to be. Now, it is positive, so we're going to be moving counterclockwise from this positive x-axis here. So we have a positive angle measure, and it is going to be moving counterclockwise. So this is pi over 2 plus another pi over 2, that's a full pi, plus another half, that's 3 pi over 2, plus another quarter here, that's going to end us right over here into quadrant 4. And that's going to be 7 pi over 4. So drawing our terminal side here, that's going to look something like this. So if we go ahead and show that, this is going to be from 0 all the way around. This is going to be 7 pi over 4. Theta equals 7 pi over 4. And if you want to convert this to degrees, feel free to do so. That's going to be 315 degrees. So what is our reference angle going to be? Well, it's just going to be in relative to the x-axis, which is here. So the reference angle is going to be this acute angle, as always, which is right over here. So looks like that is going to be 45 degrees away from the x-axis. And in terms of radians, that is just going to be pi over 4. So hopefully that makes sense, because if 90 degrees is half a pi, then 45 degrees is going to be a quarter of a pi, or half a pi. The reference angle for 7 pi over 4 is going to be pi over 4. For number 6, we have this angle measure of theta equals 5 pi over 6. Let's go ahead and put this on a coordinate plane. Now 5 pi over 6 is less than a full pi. 5 pi over 6 is less than a full pi, so we're going to actually start from 0, and we're going to end at 5 pi over 6. We're actually going to be 1/6 of a pi away from a full pi, so we're going to stop a little short of that horizontal, or that negative part of the x-axis. So 5 pi over 6 is going to end up somewhere right over here. Just a rough estimate. So this is going to be our theta in this particular example. So theta is equal to 5 pi over 6, which hopefully that makes sense. It's less than a full 6 pi over 6, or a full pi. Now what's our reference angle? Well, it's going to be relative to the x-axis. So here's the x-axis. Our reference angle is going to be this angle measure right over here. Now if we are going to be, let's see, 1 pi over 6 smaller than this is going to be just pi over 6. If it helps you to see what that is in degrees, then you can say that's equal to 30 degrees. Okay, so 30 degrees is the same thing as this pi over 6. And so our reference angle for this example is going to be pi over 6 in radians, or 30 degrees if we're measuring it in degrees. Here's number 7. For number 7, we have this angle measure of negative 11 pi over 3. So we have to move in our clockwise direction this time. Let's go ahead and check this out on a coordinate plane. So that's going to be, this is going to be the initial side of our angle. And we're going to be moving, let's see, negative 11 pi over 3 around. So we're going to be moving in that clockwise direction. So if we move, let's see, we hopefully know, we can put on the side here that 2 pi is a full circle, right? 2 pi is a full circle, it's 360 degrees. That's going to be the same thing as 6 pi over 3. Okay, that's a full revolution. But we also know that if we go in 2 full revolutions, or 4 pi would be making 2 full circles. That would be 12 pi over 3 here, right? 12 over 3 is equal to 4. So this should be just a bit shy of making 2 full revolutions. So if we're starting from 0 and we move a full circle around, that's going to be 2 pi, or also known as 6 pi over 3. Now if we just keep going around again, because we're going to 11 pi over 3, or negative 11 pi over 3 rather, we're going to have to stop 1/3 of a pi short, which is going to end up right around here. Okay, so we're going to go ahead and draw the terminal side here, this right over here. So the angle measure is actually pretty interesting, because we start here, we loop around, okay, that's going to be 1 full cycle, that's going to be 6 pi over 3, but then we end all the way over here. So it was actually more than 1 whole revolution around, and so we can call that theta. That is going to be negative 11 pi over 3. So if it's more than negative 6 pi over 3, then we knew we were going over 360 degrees, or more than a full revolution around. Now what about our reference angle? Well, it's going to be relative to this x-axis, and that's going to be just this angle measure from the distance, I guess, between this terminal side and that horizontal line. And so we know that we are going to be 1/3 of a pi, or pi over 3 away from the x-axis, because 11 pi over 3 plus pi over 3 would be 12 pi over 3, and that'd be back at 0, which is the same location as 2 pi and 4 pi. And if you want to know what this is in degrees, this should end up being 60 degrees here. Pi over 3 would be our reference angle for negative 11 pi over 3. Here's one final example we can look at together here. For number 8, we have theta is equal to negative 7 pi over 6, so another negative angle measure. And so let's go ahead and start off by putting this on a coordinate plane. So we have this initial side, this is going to be at 0 radians. And let's see, we have a negative angle measure, so let's move clockwise for this one. And so let's see, again, like we talked about earlier, if we know we're moving pi units in either direction, that's just 180 degrees. Pi is going to be the same thing as 6 pi over 6, right? That 6 divided by 6 is just going to equal 1. And so that's a good reference point to kind of know where we are going. And so we're moving 7 pi over 6, which is going to be more than 180 degrees. So here is going to basically be 3 pi over 6. This is going to be 6 pi over 6, or negative 6 pi over 6 since we're moving clockwise. Because of an improper fraction, it's going to go a little bit past that, right? So this negative 7 pi over 6 is just going to be a little bit past the horizontal here. So it's going to be, let's see, it's going to be this angle measure moving from here all the way around to here, okay? And so that theta is going to be negative 7 pi over 6. That's also known as negative 210 degrees. And so our reference angle is going to be relative to this x-axis or horizontal axis, and that's going to be this angle measure right in between. So if we go ahead and say this angle right here, that is just going to be pi over 6 since we went pi over 6 past it. And if you wanted to put an angle measure, that would be 30 degrees past it because we are 30 degrees above it, and pi over 6 and 30 degrees are equivalent to each other. And so the reference angle for negative 7 pi over 6 is going to be 30 degrees, or in radians, that's going to be pi over 6. So there you have 8 different examples of writing reference angles for different angle measures, whether they're in degrees or they are in radians. Go ahead and just maybe sketch so you can see the location and see what it looks like. Wherever that terminal side ends up, just go ahead and see how far it is from the x-axis. It's always going to be an acute angle for that reference angle, so maybe that'll help you make sure you are going to the right location. Okay, so hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.